Hi, today I'm going to be doing this complex power problem from homework 9. So we have the circuit shown below is operating in steady state. The load absorbed 5070 with the angle of negative 34 volt amps. The voltage source delivers 7500 watts. And find all the possible values of L of A. And we are given Vs of t, which is 400 cosine with 100 plus t plus 38 volts. So let's try to solve this. First, we'll start off by writing down everything they gave us. So we have the power of the source, which was 7500 watts. We have what the load absorbed, the apparent power, which is 5070 with an angle of 34 volt amps. And this can also be rewritten as 4203.2 minus 2835.1 J volt amps. And this is going to be the power of the load, and this will be the reactive power of the load. Okay. And so we have Vs of t, but it is not converted to the RMS. So we'll do that by just dividing 400 by the square root of 2. And then we get the volt source RMS is equal to 282.84 with the same angle, 38 degrees. Okay, and so from this information, we can solve for IRMS. So we do that using this equation. The power of the source equals IRMS squared times the resistance of the circuit. And so we can rewrite this as IRMS squared and 3.3 ohms plus the resistive load. We can rewrite it as this because this is equal to the resistance of the entire circuit. And we were already given the power of the source, so we'll just plug that in there, 7500. And then we get 3.3 ohms times IRMS squared. And then IRMS squared times RL is just equal to the power of the load. And we were already given that. I mean, we solved for that already, which was the 4203.2. That's why it's important to rewrite the apparent power. And then solving for this, we get that IRMS squared is equal to 999 amps. Then we take the square root, and IRMS equals 31.607 amps. Okay. Then we now have enough information to solve for the angle of the source. And we want that so then we can solve for the reactive power of the source. So we have PS equals VRMS, the magnitude of IRMS, and then cosine theta. So then we can just plug in the values that we already know, which is 7500 watts. The magnitude of VRMS, that would be the 282.84. And then we already solved for IRMS, that was 31.607, and then cosine theta. So solving for cosine theta, we get that it is equal to 0.83895. And then solve for the angle, we take the cosine inverse of that. And we find that the angle is 32.97 degrees. Okay, so now we want to use that to solve for the reactive power of the source. So QS equals VRMS IRMS, then sine theta. So very similar to the power source, the power equation. Then plugging in everything, we get that the reactive power of the source is 4,865 bar. So since we have the power and the reactive power of the source, we can also write down the apparent power. That is 7,500 plus 4,865 J volt amps, and this can also be rewritten as well, actually, for this case, we won't need to rewrite it. And so now we have QS and QL, and then we can now solve for the reactive power of the line. And so we have this equation, which gives us the reactive power of the source. But we already solved for the source, but the reason we rewrite it is because we can rewrite this equation to solve for the reactive power of the line, which is this. And solving for the reactive power of the line, we get that it is equal to 7,700 bar. And now, using the equation of the reactive power, we can solve for the value of LA using this equation. The reactive power of the line times IRMS squared times X, and in this case, X can be rewritten into WL of A, and then the W is the frequency. Sorry, it's not the frequency, but it's given by the equation of Vs, which is the 100 radians per second. So we'll just plug in 100 there. So we have I. And then we already know the reactive power of the line, so we can solve for LA. And solving for it, we get that it's equal to 77.1 millihenry. And that is how you solve problem 1 of homework 9, complex power. Thanks.